Hi guys, today we're gonna go ahead solve another system of equations in three variables. So we are asked to solve algebraically, and the reason why that's specified is because in later units we will be introduced to other techniques where we can use our graphing calculator, and so that's why. Okay, so we are asked to solve algebraically. So in short, I want you to use the substitution or elimination. Together we're gonna solve by elimination. So gentle reminder, to solve a system of equations by using the elimination method, step 1, write all equations in standard form. So standard form for two variables, it's ax plus by equals c, and for three variables it's x, y, z equals constant. Okay, but to be more specific, it's that. Okay, so standard form, variables on one side, constant on the other, and all of these are in standard form. So to solve a system of equations by elimination, if we have a system in three variables, let's go ahead pair up equations and then eliminate the same variable from each pair. So let me go ahead number these equations 1, 2, and 3. And the question is, which one should we pair? It's a personal choice. I guess we can try to which one should we eliminate? So in this case, my eye is being drawn to 2x because these coefficients are already opposite. My eye is also drawn to eliminating the z's because these coefficients are opposite. To tell you the truth, I would probably eliminate z. The only reason why I'm not going to is because in the other video, in the first one, we eliminated z, and I don't want you thinking that you always eliminate z. So together we're gonna go ahead and eliminate x, and then if you want, you can redo this problem and eliminate z. So let me go ahead speak to myself. Let's go ahead eliminate x. So now that we established which variable we want to eliminate, we can safely pair up equations and eliminate that variable. So we're gonna say pair, I'm gonna do 2 and 3 because those were the equations that caught my eye in terms of determining what variable to eliminate. So let me go ahead write that. Yeah, I wish I wrote a little bit faster, but that's not happening. Okay, maybe I should put like music in the background, you know, but yeah, that's not gonna happen. Okay, cool. So we're gonna pair equations 2 and 3 and eliminate x, and then we want to do our other pair. So we make two pairs. So again, we have three equations. We already used two. I gotta watch my fingers because I love my job. I think I'm in the safe zone. Okay, cool. Pair means two, so we have one, and we're gonna have to recycle one of those two other equations. So we're gonna have to for sure use one, and then I'll pair it with I'm gonna pair it with equation 3 because one of the coefficients is positive and the other one is negative, so that will avoid having to multiply by a negative. Okay, so we're gonna go ahead pair equation 1 and 3. So equation 1 reads x plus 2y minus z equals negative 5, and equation 3 reads negative 2x plus 2y minus 3z equals 6. Fantastic. So again, to solve a system in three variables by elimination, so one, we're gonna pick a variable to eliminate. How are we gonna do that? We're gonna make two pairs of equations and eliminate that variable. So in this case, we said let's eliminate x. The coefficients are opposite, so we have green light to add the equations. The sum is 0 as expected because we said eliminate x. The sum of the y's will give us negative 2y. The sum of the z's will give us negative 2z. And the sum of the constants is negative 6. Please watch those signs. All too often, students forget the signs and they'll put like 18, you know, because they didn't see the negative. So let me go ahead highlight this because we're going to do a lot of work. So the second equation, we can quickly add the equations because the coefficients are not opposite. The least common multiple between 1 and 2 is 2. So let's fix it so we have a positive 2 and a negative 2. We already have a negative 2, so let's get that positive 2. So to do that, we're going to multiply the top equation by 2. Okay. So let's go ahead and write our new system. So our new system will give us 2x plus 4y minus 2z equals negative 10. And then the bottom equation was apparently perfect. Okay. So we have fixed it so the coefficients are opposite. Let's go ahead add the equations to eliminate the desired variable. So when we do, that will give us 6y minus 5z is equal to -4. Fantastic. So let's go ahead create our new system by joining our new equations. So we have -2y minus 2z equals -6, and then we have 6y minus 5z is equal to -4. So yes, our system has the variables x, y, and z, but we're going to focus on this system, okay? So our new system has the variables y and z, so we have to find y and z before we can think about finding x. You can solve this leftover system by substitution or elimination, but I'm biased towards elimination, so let's go ahead and do this. So I don't really care if you try to eliminate the y or the z. The way I choose it, I try to work with smaller numbers. So if I wanted to eliminate the y, we would need to have a +6 and a -6. If I wanted to eliminate the z's, we would need to have a +10 and a -10. So I'm like, okay, do I want to work with 6's? Do I want to work with 10's? Yeah, like you, I want to work with 6's. We want to work with smaller numbers, okay? So let's eliminate y. The least common multiple of the coefficients is 6, so we want a +6 and a -6. We already have a +6. Getting the -6, it's an easy fix. Let's multiply this -2 by 3. Well, it's not just the term. We gotta multiply the equation itself. So when we do, that will give us -6y minus 6z equals -18, and apparently the bottom equation was perfect. Cool. So the coefficients are opposite. Let's go ahead and add these equations to eliminate the desired variable. So when we do, that will leave us with -11z is equal to -22. For the grand finale, let's go ahead divide both sides by the coefficient, and that will give us z equals 2. Whew, I'm exhausted. Okay. So our system has the variables y and z. We found z. We just need to find y. Okay, so let's go ahead put a love note. Find y. So you pick whatever equation you want. Both of them are pretty scary. Which one scares me the least? I'll just pick this bottom one. Okay. So we have 6y minus 5z equals -4. We want to find y. So we're going to have to know the value of z, which is 2. So we have 6y minus 5 times the value of z, which is 2, equals -4. And that will leave us with 6y equals minus 10 equals -4. Work your magic. Isolate the variable term. And that will leave us with 6y equals 6. And when you keep your cool after you divide both sides by 6, that will give us 1. Cool. We found the y, we found the z, so now we have the green light to find the third and final variable. Let's go ahead and speak to ourselves. So we're gonna find x. Okay, so to do that, you're gonna pick any equation that has the variable x. So let's go ahead, scroll back up. Which one scares me the least? Probably the top one, because the coefficients seem to be smaller. Okay, so that top equation reads x plus 2y minus z equals -5. We want to find x, so we have to know what y is and what z is, and we do. We have y equals 1 and z equals 2. So we have x plus 2 times y, which is 1, minus z, which is 2, equals -5. It's all arithmetic, guys, okay? Don't lose it at the end. Keep your cool. So that will leave us with x plus 2 minus 2 equals -5. And how about that? Difference of 2 in itself is 0, or we say that cancels out, and that will give us -5. The popular mistake is that students would just box the z equals, y equals, and x equals, but the instructor has no time to hunt for your answers, so please put it in the proper notation. You need the order triple. You don't need to write this, but the reason why I write this statement right here is just to put me on track, to remind me that it's x, then y, then z. Just sing the alphabet, you know? Cool. So x is -5, y is 1, z is 2, and after all that hard work, we're going to tell the reader that the solution is given by the order triple, -5, 1, 2. Fantastic. So guys, so remember, we're doing a total of 5 problems because we're overachievers. This is the second one, and we have 3 more to go. Thanks.